Hello and welcome to podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app or want to try out a project you hear about on the show, you'll need somewhere to deploy it, so take a look at our friends over at Linode. With the launch of their managed Kubernetes platform, it's easy to get started with the next generation of deployment and scaling, powered by the battle-tested Linode platform, including simple pricing, node balancers, 40 gigabit networking, dedicated CPU and GPU instances, and worldwide data centers. Go to pythonpodcast.com/Linode today, that's Linode, and get a $60 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. You listen to this show to learn and stay up to date with the ways that Python is being used, including the latest in machine learning and data analysis. For more opportunities to stay up to date, gain new skills, and learn from your peers, there are a growing number of virtual events that you can attend from the comfort and safety of your own home. Go to pythonpodcast.com/conferences to check out the upcoming events being offered by our partners and get registered today. Your host, as usual, is Tobias Macy, and today I'm interviewing Ken Youens-Clark about his book, Tiny Python Projects. So, Ken, can you start by introducing yourself?
Oh, hi. Thanks for having me on. My name is Ken Youens-Clark, and right now I'm working as a senior scientific programmer at the University of Arizona. And have been working for the last 20 years or so in a field of computer science and biology gets mashed up into something that we call bioinformatics. I think one of the things that maybe sets me apart a little bit is that I had no formal training in computer science or biology. I studied English lit and music in my undergrad so many years ago, and then taught myself programming, and then taught myself biology, and that's where I got where I am right now.
Yeah, it's always interesting when people are able to find their way into the field without having any official academic training. And it just goes to show that while those are valuable, they're not necessarily the be-all, end-all or a determining factor in terms of your available skills.
Yeah, I think that what is definitely necessary in this field and will definitely continue to be is just the ability to learn all the time, to teach yourself, to find materials that will help you progress, because even though this book's about Python and Python is extremely popular, in 10 years, 20 years, what's going to have supplanted it? And
do you remember how you first got introduced to Python?
I started off programming in a number of different languages, and then really fell into Perl in the late 90s. I really wanted to get into web development, and then Perl actually was my gateway drug, if you will, into bioinformatics. Especially in the late 90s and the early 2000s, Perl was just really king at text processing, which is a lot of what genomics and web processing, web programming was too. And so it was actually a few years ago, helping my boss, Bonnie Hurwitz, at the University of Arizona, we were teaching courses to teach beginning programming skills to biologists. And we were teaching Perl because that's what we're really expert in, and what had been the predominant language in that field. But it really was becoming more and more apparent that Python had really won the space, especially when it came to a lot of scientific programming. And so I really pushed Bonnie to change the course over into Python, and I decided I should just basically abandon all my Perl programming and just become a Python programmer, so that I could really understand the language well enough to teach it. And so I'd say it was about 3 years ago. It was just a conscious decision because of the prevalence of Python in scientific programming to just simply go. And really I found, there's so many similarities between Perl and Python. I did not find the move to be really at all difficult.
And I know that in Python, there are actually a few different libraries that are being used heavily in bioinformatics, BioPython being the one that comes to mind first. And then there's also a new language that's inspired by Python in the form of Seek that is targeting that same area. I'm curious what your experience has been in terms of working within that ecosystem in your day-to-day work.
I definitely have found that Python, this, like you mentioned, BioPython and so many other modules really make programming in genomics and bioinformatics really pretty easy. There's a few gotchas that you definitely need to be aware of, as is with any language. Python especially, with its dynamic typing and some of its ideas about kind of variable overloading, operator overloading, you really need to be super aware of some of the things that you're doing, or you can really mess up your data. But I also was able to, while I've been at the University of Arizona, I was able to complete a master's degree and did an introduction to machine learning. And so that's another area where Python has just really excelled the community with delivering just incredibly useful modules. I think that I have come across that Seek language. I think I looked at it briefly and found it somewhat interesting, but I'm not necessarily I'm not convinced by it yet.
Yeah, it's one of the challenges of any new entry to the either languages or libraries, where it takes a little while to get to a point of maturity where more people are going to adopt it, and there's only a small cadre of people who are going to jump on board early on to test its mettle.
Yeah.
And so now you have written this book, Tiny Python Project. So I'm wondering what your motivation was for writing it and your goal for what you're hoping to achieve with the book and the types of lessons that you're trying to provide.
Yeah, so I would say that the inspiration really, it directly came out of the teaching that Bonnie and I were doing at the University of Arizona. So we're trying to take biologists who don't have a formal computer science background, and we're trying to give them in one semester basic programming skills. Like, I need to, at the end of this course, I need to be able to, process a directory of input files and parse through them and output some result. And so practically speaking, like, what can I teach someone in 12 to 14 weeks of class time, at the end of which they will have gone from zero to being a somewhat self-sufficient programmer. And this was really influenced by when I got into bioinformatics in 2001, because I got hired by Dr. Lincoln Stein at Cold Spring Harbor Laboratory up in Cold Spring Harbor, New York. And he was a big Perl guy. He's got many books to his name. He had modules that he had written that were part of the standard core Perl distribution. I had no idea what bioinformatics was, but I knew that he was a big figure in the community. And when I had an opportunity to take a job in his lab, I was like, sure, I'll do whatever you want to do, because I'm happy to be working in Perl and happy to be working with this really smart guy. And one of his core programs that he started, and he got funding for it. He did this for like a dozen years there, but he had started this programming for biologists class where he had people come to campus for 14 days. And it was intense. It was like drinking from a fire hose, 12, 14 hours a day, getting these postdocs and graduate students and sometimes career professionals in a room and just starting them. Here's the command line. Here's how you run Perl. Here's how you run these basic programs that we use in bioinformatics, so that at the end of 2 weeks, they're kind of sort of on the road to becoming computational biologists. And so we started off at Arizona, Bonnie and I, using those same materials to teach biology. And like I said, after like a year or so of doing that, you're just like, we really should be changing this into Python. And so I started having to write my own materials to do that. I guess I didn't have to. I chose to. I really wanted to. I felt like I had a vision for the way I wanted to teach programming. And over the course of a few years of working with students and trying to grade a bunch of assignments, I just realized that providing test suites just really made my life so much easier as an instructor. It really helped the students to understand when their programs were working. And then for me as the teacher, all I had to do was pull their assignments from GitHub and run the test suite. And their grade was simply a percentage of the number of tests they passed. And so I just really started embracing this idea of teaching by using test-driven development. And there just really wasn't any material out there. And the more I looked, really testing seemed to be this idea that's like, oh, once you get into industry or once you're a senior level programmer, you'll really understand the importance of testing your software. And I thought that was just really short-sighted. I think we should be teaching testing to the novice, to the very beginning programmer. So, in my book, in the first chapter, we program Hello World, and then we write a test for it. And we say this program, when we run it, should say hello world. And we test it. And, and it lets you see if you miss the exclamation point or the comma, or you put an extra space in there, you fail the test. It's not close enough, it's not good enough in programming. It has to be perfect. And especially in bioinformatics, we suffer from poorly trained people writing, Perl and Python scripts and barely putting them into some sort of source code repository. And then you go to try to pull their work and reproduce their work, and it's completely unreproducible because it has all these hard-coded paths. It makes all these assumptions about the environment. It hasn't been tested in even the slightest way. And so I think as an industry, we need to rethink where and when we start teaching testing. And I think it should be taught right at the very front. And so the book is written in a way that there's like 22 chapters, and every single one, I describe a program that you should write, and I say there's a test suite there that your software should pass. And when it passes, you're done. That's it. That's the expectation for that. And hopefully, as we go through the material, I start saying, oh, let's look inside this test. Let's see how it works. Let's see what it's doing. And then by the end of the book, I'm asking you to look at the integration test, to write your own unit test. Like if you're going to use this function, here's a unit test. But if you're going to write a different function, make sure you write a unit test. And so I hope by the end of the book, you really understand Python deeply because you've used the test, but also I hope that you understand testing itself, which is not limited to Python, which you could take those skills to any and every other language that you work with.
And test design is an entire science and art form in and of itself beyond just standard software engineering. And there are a number of software engineering principles that go into it. And they also will impact the way that you approach the design of your code in order to make it testable, which I know is one of the main goals of test-driven design. I'm curious what you have found to be some of the outcomes for the people that you've worked with this material of introducing testing as an early concern and some of the ways that has helped them in their overall growth as software engineers.
It's interesting. I think that when you can make something fun, I think it makes it easier to learn. It was interesting to me when I bought a Prius a few years ago. And there's like this dashboard that gives me real-time feedback, like for how I did on my start and my coasting and my braking. And every time I do those actions, it gives me immediate feedback like, oh, you used too much energy on that start. So it's basically teaching me how to drive the car, which I thought was really interesting. And it actually becomes a game because it gives you a score at the end. And I'm like, oh, can I beat my wife's score, on how she got a 97 the last time she went to the grocery store. And oddly enough, I think that taking these students and giving them this test suite, and okay, so there's 10 tests that their software has to pass, the first of which is, did you create a program that was called, food.py, whatever it's called. And so, the first couple tests are pretty easy to pass, and then it gets a little harder and harder. And honestly, watching them pass one more test and they get excited, and they pass one more test and they get excited, and then they pass the whole thing 100%. And I literally see like undergrads and graduate students like kind of pump their fists like, yes, I did it. And I think oddly, the test can actually be a really positive reinforcing thing. Instead of beating you down and saying, no, your software doesn't work. It's like, hey, you just passed another test. You're closer to the goal. And so I think that normally when you as a professional, you're not going to have this pre-written the software suite that you're going to code against. You're probably going to organically create the code, create the unit test, create all this kind of at the same time. I really teach test-driven development, though. I really think if you're going to write this function, first go write the unit test. Like think about what's the data you're going to pass in, what do you expect to get back, and then go write that function. But it's going to grow over time as you write your program. And I think that I only have a chance really to work with kind of near beginners and work with them in their first few months of coding. And so I don't necessarily know if it has this long-term effect that they will continue to keep writing code, but especially in the sciences, we really prize, or we should prize, reproducibility. And I think that this really gets at the heart of proving that your software is reproducible. And the other things that I'm teaching there is that the programs, in order to be tested, they have to be parameterized. So, if your program takes an input file, that should not be hard coded. That's a parameter. It's a command line argument, so that I can test it with 2 or 3 different input files. And so because the way that we make our programs parameterized in Tiny Python projects is we're using the standard argparse module, then it just automatically generates documentation, and it creates this interface for your program. And I think that people, when I've worked with them, I think it seems overwhelming at first, like, oh my God, I just want to print hello world, and I have to add all this other stuff. But it's really not that much to add. And in the first chapter, I try to step you through, like, okay, here's how to print hello world. But now we want to make it hello something parameterized, something that we can pass in. And here's how we can do that. And I think that you do that the first 2 or 3, maybe 4 chapters, and it seems kind of challenging. But then after that, I think it starts to make sense. And people really come to appreciate that this is a pretty sane way to write software and to make sure that it works.
And in terms of the actual test design too, I know that there are several different patterns, whether you're using given, when, then, or arrange, act, assert. And I'm curious what your strategy is in terms of making it easy for your students to be able to understand the test setup and the structuring of the tests when they go to the point where they're writing them on their own rather than just using the ones that you've provided for them.
Right. Yeah, this is a really great point. And so when I learned I really kind of taught myself how to do testing in Perl. And Perl has some really great testing libraries and a testing harness, and it works very similar to PyTest. And so when I got to Python, and I was looking around, there's unit test, and then there's PyTest, and there's some other frameworks. PyTest was the one that was the most immediately recognizable to me. It was very similar to the way Perl ran it. PyTest, you can just name your test, like your integration test. If it's a file that contains test, you can just name it test underscore, whatever, and it will find that, and then it will go in there and find any function that starts with test underscore and run it for you. And so, honestly, I find PyTest to be so dead simple and easy to use that I think it takes just a couple of examples of how to run it and how to structure your tests. And then I just teach using like assert statements. And I really teach a functional programming approach to writing Python. The book does not even attempt to address object-oriented programming or testing objects. I stick just with how do you write a function, how do you write a test for that function, and then a little bit later, how do you test your whole program from the outside using an integration test? And that's what I'm providing, is I'm providing these integration tests that from the outside, they run the program and see, does the program create the expected output? And then about halfway through the book, I start saying, okay, it's time for you to start writing your own functions, and we need to start writing those tests for those functions. And those tests can live just right there in the source code, or you can put them into a separate like unit file if you want. And so I think that with more than anything, what people need to learn programming is copious number of examples. And so I try to provide lots and lots of programs with lots and lots of functions and tests for those functions so they can see all the different ways that they could incorporate these ideas.
And as far as the experience of the students that you're working with and any early reviewers of your book, what are some of the types of problems that you see them run into as they're being introduced to these tools for testing and linting and being able to do things like using MyPy for type annotations, and just some of the complexities or difficulties that they reach and your strategies for helping them past those hurdles?
Well, unfortunately, one hurdle is just kind of the Unix Windows divide. I always get about half my students are on a Windows platform, and sometimes even like on something like a Chromebook, which has presented its own problems. But on Windows, really, to get an environment that really works, I think, effectively, you really need to install Windows Subsystem for Linux. And that has its own complexities, but I think it's getting a lot better. There's a lot of things that without Windows Subsystem for Linux, Python works really differently from Windows to I work on a Mac, so I'm really working on a FreeBSD, and most of my work, especially in scientific programming, is on Linux platforms and virtual machines and such. And so that's a challenge, is kind of converting the Windows user over to the command line interface and kind of understanding things like your path, and Python path. And that's definitely challenging, especially for any beginner, really. And then to kind of explain like that there's all these separate tools, like you say, like Pilot. I really recommend that you use a code formatter. For instance, I stress in the book that all the examples that I show have been formatted with YAPF, yet another Python formatter, but that there's also Black, and there's other tools that you can use. I try to show what Pylint, what that can do for you, and why it's really worth your time to run Pylint on your code to find errors that Python would just kind of gloss over at runtime, and it would just run, and it might blow up or it might not. Some of the suggestions from Pylint are just about spacing and stuff, and that's fine. So, but we can use these tools like Pylint and YPF to just automatically make our code look much prettier, which honestly makes it easier to read and to understand. So it is difficult. Like I will see students just have this like jumble of hand formatted code that does work and does pass the test. And I'll be like, just go up here and click on format code. And then, bam, their code is all of a sudden so much prettier. And they're like, oh, okay, yeah, that's really a lot nicer. So, it takes time, and I think it takes a lot of examples. I think that the code examples I present in the book are clean, and I try to keep them very short. Pretty much all the programs are 100 lines or less. Sometimes they're like 40 lines, but they're complete programs that I think can easily read and look at and see the structure. And I think that hopefully it convinces people to use these tools. And now one note about MyPy, it's not until the very last chapter that I introduced the idea of type hinting. I tried to introduce it earlier in the book, and I felt like maybe it was too much information at that stage, because I am trying to target the novice programmer. So I kind of save it to the end, and I introduce the idea of type hinting and why MyPy gives you this just whole other level of information about your program. And if I have an opportunity to write a more intermediate book, intermediate to advanced, I would start at that point. I would start with every line of code being with type annotations, and some more advanced tricks that I tend to use in my own programming.
And then you mentioned that the programs that you're working on in each of the chapters are 100 lines or less, which is challenging in that it provides this constraint of needing to keep things approachable and conceptually simple, but still interesting and useful enough to be able to encompass the entirety of the concept that you're trying to present. And I'm wondering what types of challenges you faced in trying to identify different projects that can be self-contained in such a small number of lines of code while still being valuable and educational for the reader.
Well, just one of the things that I really try very hard to make the book interesting and lighthearted. And so, part of what I wanted was that the challenges should be on their face in some way amusing or interesting. Like in my very first example, when I started off, it was just choose the right article. So given a word like apple, you should put an in front of it, A-N. And given a word like guitar, you should put A. And my editor was just like, geez, this is boring. Can you spice it up a little bit? And I said, yeah, actually, it is pretty boring. And so I made it into the crow's nest. And then you have to say, ahoy, Captain, there's, an octopus off the larboard bow. And I don't know, maybe that made it funnier or not, but it was somewhat more interesting. And then I started drawing these cartoons to try to just, lighten it up a little bit, make it feel a little more human. But there's so much to learn from something as simple as, how do you take a positional argument on the command line? How do you determine if the first character of that case insensitive is a vowel? What does it mean for something to be a vowel? How can you compare that letter to all the vowels? How can you then use that information to do conditional branching to choose the letter A, the word A or the word and? And it gets you into string indexing and string methods like upper and lower, using, say, like X in Y. So is this character in the list of vowels? For the conditional branching, it allows me to introduce if-else statements. But then since this is simply a binary condition, it's either A or N, then I can turn that if statement into an if expression and show the same concept that took 4 or 5 lines of code. Now I can do it in exactly 1 line of code. And to talk about all these things that, like, one of the reasons why the programs are as short as they are is because I try to show the most elegant solution I can think of in Python. And actually, I tend to show multiple ways to solve these problems. And sometimes I start off with a very long-winded way, or somewhat long-winded way of solving a problem. And then I show, well, here's how we can shorten that, those 6 lines of code down into 2 lines of code. And it's not just about golfing your code. It's not about, some sort of a alpha male, like I know how to write really short, brief code. And it's really about, like, here's a more elegant way to write that same idea, whether it's like a list comprehension, which was something entirely new to me when I came to Python. And it took me a while to embrace it, but then I was like, oh, yeah, list comprehension, that's actually pretty cool. And then as I go further into the book, I really start drawing on ideas from purely functional programming languages. And I really start trying to introduce you to ideas of like map and filter and reduce, really powerful concepts that allow you to start thinking in the terms of functions and how you can fit functions together. So, but I start from the beginning just with strings. That's the first chapter. Second chapter is lists, like what can I do with the list? Third chapter is dictionaries. And then I start introducing files and input, output, handles. And then we get into, I spend a few chapters on regular expressions, which I think is something that most people, especially novices, have never even heard of that. It sounds really, really scary, regular expressions. But, I try to come up with, like, Mad Libs, how I think probably everyone, maybe not everyone, but lots of people have probably tried to create a Mad Libs implementation. It's a great thing to do. And so I try to show you how to do Mad Libs both with regular expressions and without. As far as like what I was trying, I had some ideas of what I felt like needed to be taught. And then I just found examples. And most of these, I've been programming these little example things to teach in class, for years. And I just kind of picked the ones I thought were the most amusing and might translate the best. And like you say, of course, I'm trying to get this into a book. I'm trying to make the code fit on 1 or 2 pages with the code annotations. And so, I'm trying to keep these programs very focused on whatever it is I'm trying to get across in that chapter. And then hopefully they're also a little bit funny.
This portion of podcast.init is brought to you by Datadog. Do you have an app in production that is slower than you like? Is its performance all over the place, sometimes fast and sometimes slow? Do you know why? With Datadog, you will. You can troubleshoot your app's performance with Datadog's end-to-end tracing, and in one click, correlate those Python traces with related logs and metrics. Use their detailed flame graphs to identify bottlenecks and latency in that app of yours. Start tracking the performance of your apps with a free trial at pythonpodcast.com/Datadog. If you sign up for a trial and install the agent, Datadog will send you a free t-shirt to keep you comfortable while you keep track of your apps. And then the structure of the book, I was noticing in the chapters that you outline the problem, but then after you've gone through the solution, you have sections of digging deeper and additional steps, or here are some other things that you can try. And I think that that's definitely a very useful exercise for people who are learning programming. It gives them some way to move off the guardrails a little bit and make mistakes and try things out for themselves after they've already gained a little bit of confidence in building the initial implementation and then seeing, well, if I experiment, what else can I do? And I'm wondering what you have seen as far as feedback from your students or from people who have read the book as to the overall structure and how that has helped them in their overall learning journey.
Well, it's still really early. I haven't seen too many people haven't said like necessarily where they've gone with this. I also try to, a lot of these are very trivial kinds of problems that we're trying to solve, but they really, it's a very short step for these to have extremely real world implications, things that you can do with these skills. And so, sometimes I'm trying to hint at that this isn't just playing around. I think that one of the things I really try to stress is if you're going to, that you should extend these programs and add new features and stuff like that, but you should also add the tests for them. And I hope that makes them say, oh, well, how would I add a test? And they would open up that test.py, which is the integration test that's included in each directory. And I would hope that they would open it up and study how did I test that element of the program. So for instance, there's one of the programs, it's called the Howler. And it's basically, it reads input either from the command line or from a file, and then prints it out in all uppercase. The inspiration is from Harry Potter. A howler, screams at the recipient, and then it blows up. And so I recommend, okay, just change it so that it now does all lowercase, and write a test for that. So how would you do that? Make it, give the program an option. Like it's by default, it's going to do all uppercase, but now you go add this Boolean on/off condition, or something like that, to where it's all lowercase, and then go add the test where you have to run the program with that flag, get the output, and verify that it is actually lowercase. And I think that exercise in and of itself would be extremely educational, because it would really force you to kind of interact with, okay, I'm going to make my program do this. How do I ensure that it actually did the thing I expected it to do? Unfortunately, I really, I haven't seen as much feedback on that aspect as I would like, but, we'll see.
Yeah, I definitely think that that's useful, because with a lot of introductory books, they walk you down a predefined path, and then once you get to the end of it, you have some measure of knowledge, but you don't really know where to go next with it. And by adding these points throughout the book where there's some level of indeterminacy as to where you can go with it or what's going to happen when you try this thing, it encourages experimentation throughout, rather than just guiding them along that path and then leaving them at the end of it without any future direction. So I think that will help to foster experimentation and make them more likely to try to take next steps, either within the programs that they've already built or with some other learning resource to advance to the next level of their capabilities.
Yeah, and with the structure of the book, is every single chapter is the same. It teaches you it presents this problem that you're going to write, and then I try to give you just enough material to be able to solve it. Like if you need some background on dictionaries, I talk about that, and then I give you, and as the programs get more complicated, I say, like for instance, singing 99 bottles of beer on the wall. Okay, that's a pretty common thing to code. And I say, maybe think about here that you write a function that just produces one verse. And then you can write a test for that function. And you really only need to test one bottle of beer and not one bottle, like 2 bottles of beer. Really, if you test those 2, you can probably pass the whole thing, no matter how many bottles. And I say, you don't have to write it like this. You can write it however you want. But if you're going to write it in a different way, think about how you would write a test for the way that you're going to write it. Like, not just the test that I've provided, but if you're going to write a function, could you mimic this thing that I've just showed you to write your own unit test? And I think that I hope that kind of thinking is really going to make a difference on the reader, that they're always thinking about, I think I understand this thing that I'm writing, but maybe I should write a test for it and really verify. And I've been programming for like 24 years, and I'm pretty good at it. And I'm still amazed at how many times I think I understand a function that I just wrote, and I run the test, and I did not. I did not think about this, aspect of it, and I got back an unexpected result. And I'm like, oh, right, yeah, I didn't think about this aspect, And so, it's a really important skill to verify the things that you think you understand.
Yeah, Boolean algebra is definitely difficult to try and do in your head when it gets beyond one or two elements.
Mm-hmm. There's a lot of really tricky things in this industry, and we, I think that hubris has its place, but you need to keep it in check. You may be good, but you still need to write tests.
Absolutely. And as a book that's intended to serve as a learning resource, what are some of the elements of the Python language and its ecosystem that you consciously left out to avoid overwhelming the readers?
The biggest one is object-oriented programming. So I started programming around 96. And my first language was Visual Basic, and that was pretty much a procedural language. And then there was object-oriented was really coming up. And my next language was Delphi, which was basically Object Pascal. And I started doing object-oriented programming and learning all those ideas. And then somehow I got into Perl, and at some point Perl decided to bolt on some OOP stuff that was, I wouldn't say elegant, but it was functional. And I really wrote a lot of object-oriented code in a couple different languages for a lot of years. And then at some point, I just kept hearing about purely functional programming. I kept hearing it, and I started reading some books about it, and I started teaching myself a little Haskell. And it really made a huge difference in the way I started thinking about code. And I just basically stopped writing object-oriented code, and I just started writing functions. And I found my code was easier to understand and easier to test. And so when I wrote this book, I just consciously left out objects. In fact, I don't think I've written a really OOP kind of system in Python ever, just because I had already abandoned that style by the time I moved into the language a few years ago. And I got a little bit of pushback from the reviewers on the book. They're like, why isn't there at least one chapter on OOP? And honestly, I think that it leads to a lot more boilerplate, a lot more complicated code than it needs to be. It hides, the very nature of object-oriented programming is to hide and encapsulate data inside these, kind of opaque objects, and the data can be mutated in ways that are subtle and invisible. And I don't think that that's necessary, especially to teach to a beginner. I think, and I encourage it in the beginning, in the intro. I say we don't talk about objects. I think it's kind of an advanced topic. I think you should learn about objects. You're going to certainly encounter a lot of object-oriented code. But like I was just put on a project a couple months ago to come in and add tests for a lot of this existing Python code. Not a single test in sight that's ever been written, and most of the code is object-oriented. And I'm just like, oh boy, this is going to be really, really challenging, because now I have to mock up these objects and find ways to pass these ideas around. Whereas if they were just functions, I could just find each function and write a test for it, passing in the parameters and getting back some value or not some value. And I simply find functional style easier to teach and easier to test and easier to show on the page. I don't think that we need to get into a lot of object hierarchies. There, a few things. I think some things about the syntax, list comprehensions, I think, are a very, very elegant solution in Python. And so I really try to show, most people can, I think, grok a for loop. And I show kind of a naive way of using for loops to create structures like lists and strings. And I say, we could really just use this list comprehension, and that's something that's really kind of unique to Python, and it's quite elegant. And so I think that and also dictionary comprehensions, I think that is maybe a little advanced, maybe a little difficult for a beginner to understand. But I show so many examples of it over and over again that I hope by the end of the book, that just seems like a natural tool to reach for if you're going to be working in Python. There's only so much you can do. My publisher said, you can only move the reader up 2 or 3 notches. So if they're at a 2, you're not going to get them to be an 8 by the end of the book. You can maybe bump them up to a 4 or a 5. And so, I was kind of targeting a 1 or a 2, and I definitely want to get you to an intermediate level, a 4 or 5. So, I don't really have space to talk about like databases. I do introduce parsing like CSV files, which I think is a really good real world kind of a thing. And there's a really beautiful, the CSV module that's built into Python makes that really pretty easy to do. But I guess the biggest thing is that I do completely stay away from objects.
Yeah, functional programming, it definitely has a lot of benefits. And I think that one of the things that causes people to shy away from it is a lot of the theoretical aspects to it and the very mathematics heavy lingo that goes along with it that doesn't have to be brought in order for you to be able to actually use it.
Yeah, I never talk about monads. Trying to really get into category theory and functional programming and stuff, it is seriously overwhelming. And I don't think I'm a dumb person, and I feel seriously dumb when I read some of that stuff, or I try to open up somebody's Haskell code to learn something, and I'm like, what are all these operators? I don't understand. What is this? And so I try to keep it really, pretty much no lingo and none of the theoretical stuff. I don't talk about the fact that lists and strings are monoids. They are, and these monoidal operations are really, really fascinating. But I never bring that term in, and I do stress over and over again how interchangeable in Python strings and lists are. And, but I don't talk about the identity function of 0 and the empty string and things like that. We can't really get into folds, but I do get into reduce, which is a really, really great idea. It's kind of like a fold, I guess. So yeah, I don't want to intimidate anyone. I just want to say, here's a function and here's how we can test it. And I think that alone is worth the price of admission. If you can write code as simply as possible, and you can have tests that verify that each one of your simple little functions works in isolation, then you can start putting your functions together to compose them into larger programs that you can then have confidence that they will continue to work in the way that you expect.
And as you have worked on writing the book and going through the review process and getting it edited, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
I thought I was a pretty good writer, and I had a long way to go. So, I've learned so much about teaching, and you think you've expressed something clearly, and then a reviewer or my editor asked me to explain it better, and you go back and you have to let go of your ego, and I probably have as much or more than anyone. So it was really a humbling experience to think that I've explained something well and it just had fallen flat. And so I remember when I was filling out the book proposal, they were like, how many chapters and how many illustrations do you think you'll have? And I was like, no idea how many illustrations I'll have. And I ended up having hundreds. I started using OmniGraffle as a really great tool for creating diagrams. And I just started realizing how many times how many times in class I would stand in front of this giant screen and point to things here I'm unpacking these variables. If I'm unpacking dict the items call. So dict items is going to return the keys and values. And it's going to return them as tuples. And in a for loop, you can say for key comma value in dict dot items. And it unpacks those. And it's a really elegant way of doing that. But, in class, I would point this goes to here and this goes to here. And then you don't have that in a book. And you realize, I need to make an illustration for that. I need to have arrows and I need to make this as clear as possible. So I think that these visual representations of these ideas, I think are very, very useful. And so I ended up just creating so many more diagrams than I ever thought that I would. And then it was just, surprising the number of times a reviewer would just maybe give me some other idea that I hadn't even considered or find some other way to test the program in a way that would make it break that I hadn't anticipated. And you're like, oh, wow, I'm so glad I had this army of reviewers catching things. So mostly I would just say it was an extremely humbling experience to realize that people out there, they really want to learn these things, but it's my job as the author to make this as clear as possible and to remove any ambiguities and to just make sure, kind of I think about Hemingway, I was an English major, and I just think about how short and powerful and clean and concise his sentences were. And I was just trying to write in as clear a tone as possible and also still try to make it a little bit funny. I'm sure I have a quirky sense of humor. I hope it comes off. I hope it's makes it more interesting than just reading another technical book.
And for somebody who has made it to the end of your book, what are your thoughts on some of the useful resources or next steps for people who are interested in progressing in their use of Python or getting into programming as a career, or at least using it heavily for a tool in whatever endeavor they are engaged with?
That's a really great, I don't explicitly to recommend anything at the end, and maybe that's a shortcoming. More than anything, I hope that they've thought about, that I've hopefully introduced some ideas along the way, like test-driven development. Actually, that phrase comes from this book by Kent Beck, which I think it was from like 2002. So I mean, this idea has been around a really long time, and I point to the original book, and I'm like, if you should just keep learning more about this, and I kind of point to that there's some ambiguities about like what does unit test meaning, what does integration, like you should read about these things, you should keep looking further. I make a lot of allusions to other languages. Like I mentioned Rich Hickey as the creator of the Clojure language, and I talk about that this kind of approach would be something that probably a C++ programmer would look at and immediately recognize, this for loop kind of approach, whereas this other approach with map and filter would probably be more recognizable to a Haskell programmer. And so I hope that by kind of planting these seeds, and then regular expressions too. I mean, my God, what a deep subject that is. And so I hope that I've kind of maybe planted the seed that the reader would go off and start looking at all these other things. I joke that if you only program in one language, then you kind of suffer from Stockholm syndrome. Like you start thinking that the warts of your language are actually things to love and be proud of. And I think that it's healthier to expand your knowledge. I actually literally recommend that you try to write these solutions in Python, and then go write them in another language that you know. Like if you know JavaScript, write it in JavaScript. And if the program is called the same thing, it's possible you could even use the test suite that I include to run your other program and test it if it kind of handles the command line parameters in the same way. So I think I really encourage people to expand their knowledge, not just inside of Python, but in the general world of computer science that we're working in, and look at other languages and try to understand these bigger ideas. Like I spend like 4 chapters on regular expressions. They just kind of play a key role in 4 of the chapters. It's not like they're just about that. And I try to stress that that's a language of itself, a domain-specific language that you're going to find inside of databases, inside of command line tools, inside of pretty much any other programming language you work with. One of the exercises, actually, I was really struggling with how to craft this regular expression, and I found the answer on a Java board. And I talk about that in the book. Like, first off, you should know professional programmers Google all the time and try to find the answer to their problem. And the solution is not necessarily going to be from another Python programmer, because there I was trying to find a regular expression, and I found it in a Java board. And you know what? Exactly the way they typed it worked inside of Python, because it was the regular expression that I was copying, not the Java. And I try to stress that. So I hope that those elements, the reader would use those ideas to go forward and expand their knowledge. Specifically with Python, I do recommend that people probably explore object-oriented Python, or just object-oriented programming in general. It's an enormously important paradigm. I think that it may be too much to say that it's falling out of favor in favor of functional programming, but it's certainly functional programming ideas are really taking hold, and I think lambdas have even found their way into Java now. So we'll see.
Are there any other aspects of your work on the book, or your experience teaching newcomers to Python, or your career as a software engineer that we didn't discuss that you'd like to cover before we close out the show?
I think that it's always the case that when you teach, you learn. Things that you just kind of maybe take for granted and you think you understand, when you actually have to explain them to someone else, you realize the limits of what you thought you knew. And so I would say that for anyone, once you've learned something, pass it on. Is it Maya Angelou, I think, says something like, once you've kind of gotten to a higher station, your job is to now help other people get there too. And so I would say that, as you've learned things, maybe find someone to teach that to. It reinforces what you think you know. And so I would say that teaching has been something that has really, really affected me throughout my career. And in fact, I would like one day, if I can make this happen, to become more of a full-time teacher, helping people to learn how to program. And so that's been an aspect of especially going to the University of Arizona and getting a chance to do some teaching in the classroom has been really transformative to me. I think that I would not be the programmer that I am if I hadn't done that teaching and if I hadn't tried to write these materials. And when you're, and another aspect I would say is that everything that I've done, I would say since probably 1998 has been open source software. So you can probably find like pretty much every line of code I've written over the last 20 something years on SourceForge, on GitHub, in some supplemental for some paper somewhere. I think when you work in the public eye, just always putting your name out there on your code, I think it forces you to really take pride in your code and like you really want to put your best foot forward. And so I would say don't hide your work. Make all your GitHub repositories public. Who cares if somebody maybe steals a line of code? And in fact, maybe that makes the world a better place because you've shared a solution. And so I would say working in open source kind of science and data has really transformed the way that I think. And in writing this book, obviously, I want to look like a smart person. I don't want to look like some dummy who doesn't really know how to write Python. So, I really had to dig down and really learn the language because, as I've admitted, I really only came to Python like 2 or 3 years ago. And I say throughout the book, I know in Python, there's this idea there should be one obvious way to do something, but really I'm more of a Perl guy. And the mantra there is there's more than one way to do it. And so, I'm going to play around with that idea. I'm going to play around with how many other ways can I find to do this thing in Python. And so I think that not being stuck in any one technology, in any one language, I think that that's important for a person's growth. I think that if you recognize that you've gotten stuck in something, you need to unstuck yourself, whether that means changing jobs or changing a programming language or moving to a new city, whatever it takes, you got to keep yourself fresh and moving. And I think sharing your work with others, sharing your knowledge with others is really crucial to growing yourself and becoming a better person and a better programmer. And yeah, I think that's what I would say.
For anybody who wants to get in touch with you or follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And so with that, I'm going to move us into the picks. And this week, I'm going to choose the Marvel Cinematic Universe. I recently started revisiting those movies, watching them back from the beginning in order with my kids now that they're old enough. And it's interesting and entertaining to revisit the stories and also just see some of the ways that their cinematic style has evolved since they first began, and also just some of the background technologies like the types of cell phones that they're using. It's just entertaining to see how much things have changed in those years. So definitely worth taking a look back at some of those original Marvel movies and revisiting the storylines. So with that, I'll pass it to you, Ken. Do you have any picks this week?
That's interesting. I think I wasn't prepared for this, but I also have kids, and I don't know when people will be listening to this, but right now we're still in the midst of a pandemic. In Arizona, we're still very much, at least my family, trying to stay very close to home. And so we're pretty bored sometimes but for some reason, we've gone back and started rewatching Parks and Rec. And even though I think that the kids have seen the episodes 2 or 3 times, and this is the second time for me, there's something comforting in kind of knowing the next punchline or rediscovering it. And so, I don't know, maybe that makes me sound pretty boring to say that I just want to rewatch old television shows. But that's been something that's actually brought me a little bit of comfort and joy during these pretty trying times.
All right. Well, thank you very much for taking the time today to join me and discuss the work that you've been doing as somebody who's teaching people how to use Python and as the author of this Tiny Python Projects book. It's definitely an interesting book, and I appreciate your focus on introducing linting and testing as a first-class concern to new programmers. So I appreciate the time and effort you've put into that, and I hope you enjoy the rest of your day.
Yeah, you too. And thanks so much for having me on.
Thank you for listening. Don't forget to check out our other show, the Data Engineering Podcast, at dataengineeringpodcast.com for the latest on modern data management. And visit the site at pythonpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts@podcastinit.com with your story. To help other people find the show, please leave a review on iTunes and tell your friends and coworkers.